There we go. Now it's official. So, again, welcome everybody to our Friday Coffee Q&A. I'm very pleased to have Steve Brodet from Huntington Ingalls Industries here, formerly Hydroid. And why don't we just go ahead and get started? So, Steve, welcome.
Thanks for having me, everybody. So I appreciate the opportunity to sit here and have a chat like this.
Sure.
So the first Friday was fun, but I think keeping people engaged like this is a great idea. So thanks for inviting me.
Right. So, Steve was our first Friday speaker. I think it was August of last year.
I think so. Yep.
Oh, so a year ago, just about
Yep.
a year ago. Boy, that went by quickly.
Yeah.
Some ways it was quickly, in some ways it was like a different
Yeah.
sentence.
Yeah. It was either last week or 10 years ago. I'm not sure anymore.
Exactly. So welcome. Tell us first a little bit about you. Tell me about you and your background, and then we'll get into Hydroid and its evolution.
Sounds good. Well, thanks for having me. Again, my name is Steve Brodet. I'm an applications engineer at Huntington Ingalls Industries. My background is actually as an oceanographer, and I spent quite a bit of time putting things in and out of the ocean, mostly with the sole purpose of making maps. So I have an oceanography degree from Maine Maritime Academy. Don't throw stones, not Massachusetts. And did a lot of graduate work at University of New Hampshire, specifically in the development of sonar systems. While I was a grad student, a branch of NOAA, the Office of Coast Survey, who's in charge of making seafloor maps, bought this robot thing, and they were asking people if they knew what to do with the robot. And while I didn't have any idea what to do with the robot, I totally volunteered. That robot ended up being a Remus vehicle that we purchased back in 2003, 2004 maybe. So my job there with NOAA was trying to transition that technology to operations. So how do I use a commercially available tool or developmental tool, right, and put that into NOAA's operations for mapping the seafloor? So I did a bunch of work with that as well as other sonar systems and navigation systems for a while. And then the robot thing just kind of stuck with me. So do a little bit of collaboration with Hydroid. They hired me on about 8 years ago now in a very similar role, right, to I can't build them, right? I can't design them. I'm not truly an engineer. But what I can do is help craft the way those robots get put together to meet customer needs. And then I haven't gotten seasick yet, so I'm good on the boat. And lifting heavy things, I can do that too. So actually making the robots go and making sure that the robots that are sold to our customer base actually meet not only what their requirements are, but our requirements that help us, help the product development team think about what the next thing's going to be. So right now, currently, that's my role at Huntington Ingalls Industries. I know Erica's probably here, so I don't have a Huntington shirt, so I wore this one. So, but proudly displaying our newest product, the Remus 300, which we can talk about in a little bit of detail if people are interested later on.
Sure. That's great, Steve. So, Hydroid was the poster child of, the success of a technology transfer from Hui, to a for-profit business. Can you talk about a little bit about the history of Hydroid, what they do, and maybe lead into, what the acquisition by Huntington Ingalls Industries means?
Sure. So, a little bit of history. Hydroid was spawned out of a program, development program at Hui, to become a commercial for-profit business. Being really starting out as the world leader in autonomous underwater systems. So, for those of you who don't know a little bit from my talk last week or last month. Let's go last year. Making maps of the ocean floor is incredibly difficult. We've all seen the big blue marble. We've seen some cool shots, of what that looks like. But getting really a good idea of what the seafloor looks like and objects that might be on the seafloor is incredibly hard. We can't use light very well. Light attenuates in the water pretty quickly. Lasers the same way, right? Can only go so far. So, for a long time now, we've been making maps using sound. So sonars get towed behind boats, right? Project sound in the water, get that echo or location, that echo back, interpret that into some kind of visual that we can use to map the seafloor. That's challenging, right? The boat stays on the surface, the seafloor varies on the bottom, you get varying resolutions. So the best way to get good maps of the seafloor is get your sonars close to the seafloor as you can to optimize that, right, with a very stable platform. So an autonomous underwater vehicle, the AUV, becomes the ideal tool for that. selfishly for me for making maps, it's also really cool that we can get, the other technologies, oceanographic technologies closer to the seafloor or in the water column to get better, accurate idea what the composition of the water column is as well. So when we developed this technology and transitioned it over to the company that became Hydroid, the market thought that was awesome. Not just for military purposes, but for oceanographic purposes as well. So over the course of many years, Hydroid continued to develop new technologies, better capabilities, better accurate mapping capabilities within their robots, and started selling those commercially to military customers, to academic institutions, and other government, non-military government like myself back in the early 2000s. So
that's cool. Steve, maybe just for someone who's not familiar with it, can you just touch on the autonomous part of autonomous underwater vehicle?
Oh, absolutely. So, the robots that we make are autonomous in the sense that we will provide them with a mission profile or a plan, send that down to it, and let that robot go all on its own. It runs, can have a complex navigation solution on board to know where it's at in the water column, and follows a pre-programmed map of what we tell it to do. So it can map the seafloor, collect whatever it needs to go. So most REMIS are deployed, the smaller ones are hand deployed over the side of the boat, and the robot goes out and does its own thing without human intervention. We can monitor it. There's acoustics that we can monitor it. We can send different commands to it should we need to throughout the mission. But the whole idea is that it goes down there and does that on its own. And that was key to me in my NOAA career, right, is that we couldn't buy more ships, right? NOAA has a fleet of ships, and those ships deployed launches, and that was maximize our capability. But if I can then put robots in the water at the same time, I can collect more data in the same amount of time and let the robot do the work for me. So for our military customers, right, that takes the military personnel out of a potentially dangerous situation, right? If the military needs to understand what's on the seafloor, someplace that they're going that might be dangerous, they can send the robot instead of sending people towing sonars behind them. So the autonomy is kind of the key. And then, leveraging how well that robot can do its job, we can then start talking about putting better and more high resolution and focused sensors on them to allow them to make their maps or collect their data.
Oh, that's really cool. So on the autonomous part, obviously it knows just to come back to the boat or ship when it's done.
It'll come back to wherever we tell it to.
Oh, that's great.
So it can come back to the boat. It can come to the surface. It can dock to a line or a buoy underwater. It can start in one part of the ocean and come up in a completely different part.
So these AUVs, Hydroid started building them when? When was Hydroid founded?
2001 or 2001, I believe.
Oh, so almost 20 years.
Yep.
Of AUV development. Are there any like big wins for the REMIS family that Hydroid has built over the years? I know that one was Dr. Dave Gallo's find of the Air France jet in the Pacific, in the Atlantic. Any other stories you can tell us about what REMIS has been used for?
Well, from a business military perspective, we are a program of record. For those of you who might know what that means, it's a pretty big win as far as the military is concerned. So we have the U.S. Navy uses REMIS vehicles very regularly for mine countermeasures. So they're deployed all over the world. Hundreds of them out there doing that job. From a non-military perspective, one of the coolest robots we make, the REMIS 6000, which can get almost full ocean depth, right? Very few places on the planet that are deeper than 6,000 meters. About this time 2 years ago, REMIS 6000 found the USS Indianapolis from a commercial customer who out there looking for shipwrecks. So that was kind of a big deal for if you're a military history buff.
Oh, that's really cool. So, Hydroid was sold to a Norwegian company, Kongsberg, at one point in the past, and now you've just been acquired by Huntington Ingalls Industries. Tell us a little bit about that evolution.
Sure. So, Huntington Ingalls Industries is kind of a world leader supplying technology and capabilities to the military as well as a series of industrial partners out there. They've been building ships for a very long time. They provide a lot of technical solutions across the board for defense work. And it's been pretty clear over the last decade or so that there's a huge interest from the military community in expanding autonomy capability. So I think it was kind of a natural evolution for Huntington Ingalls Industries to decide that we want to get on board with some more autonomous solutions, and Hydroid at the time, and still is the world leader in that. So it was kind of a natural evolution for them. You know, when Kongsberg owned Hydroid since 2008, that was a great collaboration. They make robots as well. But it was just, I think it was just the next natural evolution for expanding the capabilities in the business.
Do you think that with the acquisition that Huntington Ingalls Industries is going to change the focus of your work?
I don't think so. You know, we make a very good product. We make a very good product that hits not only customer needs, but hits the military needs very clearly. So I think that it's just going to allow us more capabilities, right? I mean, we went from a company of a couple hundred people to, you know, having the support and the backbone of several thousand people within Huntington Ingalls. Sure. So I don't think the focus is going to change. I think it's just going to allow us to move probably a little more efficiently, a little quicker, to leverage on those resources.
How many people are working at the facility in Pocasset now?
So we're at total head count for all of Hydroid and Pocasset is over 200 people right now. Yeah. So, you know,
one of the fears that, you know, all of us local folks have is that when a company gets acquired, they're going to take them and move them somewhere else. Do you think that's something that's going to be in your future, or are we safe for a while?
I don't see that happening. We have such close ties, not only with Hui down there for our technology side, but, you know, a lot of our success, all of our success, in my opinion, is attributed to the technology talent that is here on the Cape in Massachusetts. So I don't see any value in relocating at all. We draw from a pretty, sorry, broke the first roll, didn't put it on mute. You know, we draw from a pretty good talent pool. Technology, and specifically marine technology, is a big deal in Massachusetts. These are where the people come, right? I'm not from here. So, you know, this is the technology that brought me to here. So I don't see that happening in the near future.
Oh, that's great. That's great. Can you tell us a little bit about the balance of, you know, what you do between commercial and military work?
Sure. So
this commercial, military, and research, is that those are three big areas?
Sure. Yeah. So commercial, military, and research academia. I don't know the exact numbers on there, but the vast majority of our customers are military customers. Our number one customer is the U.S. Navy. We also supply vehicles to foreign militaries as well. So we got REMUS in 25 countries around the world that cross the gamut between military and commercial and academic applications. As far as commercial is concerned, you know, it's an expensive tool to get the job done. So but the cool part about the commercial part is those people are really on the cutting edge. So our commercial customers help us, you know, push the envelope a little bit further, so we can meet their needs, and that will just naturally evolve into our military customers. But our primary customer is military.
Yeah. So one of the questions that came up is that what's the entry level model cost for REMUS?
I'm gonna take a softball on that one. I'm relatively ignorant in my house and how much stuff costs. It keeps me honest to go on there. But I think if you it's going to cost you a bit. I think an entry level REMUS, if I can just spitball, is going to be on the order of $500,000. That gets you the robot, the sonar capability, all the auxiliary equipment that goes with it.
Right. So it's not the price of a Honda.
It's not the price of a Honda, no. So we have been, you know, in the past, and I think we're going to explore the capabilities of developing a smaller package, a more cost-effective package. But autonomous underwater robots for the price of a car is probably not a robot you're going to, you know, we can't pack the capabilities we want in something like that.
It's not useful, and you're not making enough of them to get economies of scale.
Correct. Yeah, we in Hydroid has manufactured and delivered over 500 robots, which is a pretty big number, but it's not mass production like a car would be.
Sure, and that's 500 over almost 20 years.
Right.
I assume that's probably weighted more to later years, but still, yes. that's not a lot per year that you're.
Nope.
You know, we had the opportunity to tour the facility a couple of years ago. Jim Sullivan gave me a tour along with Erica and Caitlin, when Caitlin was there. and that was it was very impressive. And it's a wonderful campus that you have down there. And,
yeah, and that place was that place is built specifically for our purposes 5 years ago, I think now. So, and just so everybody's clear, know that, you know, we do all the design and manufacturing and testing of those robots out of our Pocasset facility. So that large building down there off MacArthur Boulevard is the first floor is our production floor. The second floor is our engineering and program management offices. Well, we built the second building soon after the first one was there that houses administration, finance, those bits and pieces. But all the design, all the construction and testing happens here on the Cape.
so that's great. Steve, do you want to tell us a little bit more about the products themselves? Maybe show us a couple of pictures.
Yeah, let me see if I can get this going on here. Just so.
Yeah, while you're doing that, Steve, this is Robin. I'm just going to jump in with some questions we're getting about the robots. One person wants to know how far away you can communicate with it. So if this thing's on the other side of the planet, you can still communicate with it, right? How do you do that?
Great question. So we have three methods of primary methods of communication with the robot. We can, if you're close by, you can establish a Wi-Fi connection to it, talk to it via your laptop. Underwater, depending on the type of acoustic systems you have down there, you could be a couple to tens of miles away. And under the right conditions, we can track and communicate with the robot up to, you know, 8 to 10,000 meters away, which is pretty far acoustically. If you're further than that and you're over the horizon, most REMIS will come with an Iridium cell phone. So it can actually get to the surface. The antenna will connect to the satellites and make a phone call. So anywhere in the world. I've gotten phone calls and texts from robots and one time in Japan because it had my phone number in it. So.
Amazing. No matter how deep the robot is.
Well, so it will, you know, when we communicate acoustically with it, right, we have to be sensitive to how deep and how far away it's going to be. So acoustic sonar modems have a limit based on the power and the frequency that they're using. So while the robot is capable of being tens of kilometers away from you, you know, you are limited, and especially with the smaller robots, to about a kilometer or two of acoustic range. So we really do rely on and trust on that, the autonomy of the system to do what it's told and to come back when it's supposed to.
How often actually do you have to communicate with it? I mean, you send it out on the job, you just kind of let it go and check in with it periodically, or do you talk to it constantly?
You can set it up to do either way. We have customers that will monitor it constantly. When I was running robots, I would let it go out and run on its own while I did something else in a completely different part of the ocean and not communicate at all. So it just depends on what your application and your need is.
Okay, the next question we've got about the robot is somebody wants to know about the AI factor.
Sure. So it would probably be best if we had software people to talk about the AI factor a little bit. That could be a pretty cool talk that's on there. You know, the autonomy we built into the robot is to follow a pre-programmed set of instructions, right? And we put in safety gates in there to tell it not to exceed a certain depth or not to exceed a certain spot, right? Or to, if you get yourself in trouble, here's some decisions that you have to make on there. So AI is going to become a thing in a much bigger platform right now. You know, Hydroid, Huntington Ingalls Industries just acquired a company that works called Sea Machines, and they develop autonomy solutions for unmanned surface vehicles. So I see that coming down the road here very soon. So they have the ability, a limited ability, to make very good decisions based on the information we provide them up front.
Okay, great, thank you. I'll stop firing questions at you so you can find those photos.
Sure. Let me see if I can get the share screen going because I have a cool graphic I want to put up here.
Steve, it's Erica. Just a quick thing, just a clarification. We, HII actually invested in Sea Machines. We didn't acquire them though. Just
sorry, Erica.
No, it's okay. I just don't want to give the wrong impression.
Yep.
They're going through kind of their funding, you know, the fundraising for their Series B capital investments. So we have invested in them.
Thank you. Thank you for clarifying that, Erica.
Thank you, Erica.
I'm glad that you're here. So I'm going to share a graphic on here. It has the wrong branding on it. Sorry, Erica. But just to show a picture of the robots, I won't go too much into it. But just so people know what we're talking about when we say Everybody see that?
Yes.
Yep.
Yeah. Okay. So this is a shot of the general family of systems that we have right now. So the one up here on the top is the Remus 100. I think you probably can't tell on the shirt that I'm wearing right now. I'm wearing a Remus 300 shirt. That's the next evolution of that. That robot is a compact man-portable system. In that configuration you're looking at there is about 6 feet long, weighs just around 100 pounds, can run from anywhere from 8 to 12 hours, depending on the payload we put out there. And then on the top is that antenna that I was talking about that has a cell phone communication if you choose to use it. The little line that's down here on the side, that's its main payload. That's a side scan sonar transducer. That's what it's using to make a map of the seafloor. Next in line is the Remus 600. Oh, and the Remus 100, the names denote how deep it's rated to go. So the Remus 100 can do up to 100 meters deep, which is most of the coastal waters that we do around, especially here in the U.S. The Remus 600 is its big brother. It is rated to 600 meters depth, can run up to 24 hours of endurance with rechargeable lithium-ion batteries. All 3 of these have rechargeable lithium-ion batteries. You can see that it's quite a bit bigger, on the order of 12 to 14 feet long, 12 3/4 inches diameter, which gives us a lot more room to cram more batteries in there for a longer duration. Also gives us more capability for higher powered or larger payloads. You'll notice that the side scan transducer here, that black line, is quite a bit bigger than that one up there. So gives you a little bit more capability. They typically can get lower frequency sonars, which can get see further out on the seafloor and make larger range maps. And then the one on the bottom is the Remus 6000. Can get almost to full ocean depth all around the world. Its architecture is a little bit different. You can't tell from this graphic, but these two, the 100 and the 600, are tubes, right? And we put the tubes together and draw a bit of a vacuum. So all the internals are exposed inside there. The Remus 6000, because it's going so deep, we actually put all of the electronics in individual bottles, attach that to a frame, and then wrap that frame in foam. So most of this yellow you're seeing down here is foam for buoyancy at depth.
Huh.
Question?
I got one very specific question here about somebody wants to know, what is the speed of your acoustic modems?
Speed of the acoustic modem. So sound typically travels about 1,500 meters per second in the water. That varies based on water density. So that's pretty fast. It'll make a ping will go out. If your robot is 1,500 meters away, it will hear that in 1 second. It'll do whatever it needs to do and then call back to you. It'll take 1 second to get to you as well. So does that answer that question?
I think maybe part of the question on that would be if you knew what the baud rate was for that.
Oh, the speed of that. I don't know the answer to that question.
Okay.
It sounds like AOL.
Yeah.
Yeah.
Remember, because the old modems that we used to use were essentially acoustic modems going over copper phone lines, and sending acoustic signals back and forth that were converted to digital. So
hold on, Mike Mulrooney. I think I saw your name pop up here. Can you answer that one? Mike Mulrooney is a colleague of mine. He's an engineer at HII as well.
I don't remember the full specs. It's something small. It's like a 32 byte message or something that we send out over that. I want to say it's close to 9600 baud maybe. I mean it's very low signal levels. There's some other capabilities that Hui's been doing to try to increase that. Some hardware and frequency modulation changes. But that's kind of outside of our realm. We at HII and the Remus technologists, look to integrate those solutions a little bit more, and not necessarily develop the sensors themselves that work with the vehicle. And we'll just take the best solution and push it forward.
great. Thank you, Michael. I remember I bought a 9600 baud modem in 1991, and we thought that was the coolest thing ever.
Steve, we've got a question here that I love.
Sure.
Because I know that you have a fantastic picture that answers this question. I don't know if you're going to be able to pull it up in time, but the question is, that someone's noticing the color of the robots. And that is a shark attracting color, and wants to know what issues you've had with sharks.
Oh, sharks, great question. So yes, yellow is a preferred color. If you've ever been out on the ocean or on a boat, if you put something in over the side that is gray or black or blue, it becomes almost invisible instantly. So the yellow is a visual cue to you as the operator that's the easiest color to see, in my opinion, of something floating in the water. Yes, I have heard that yellow is also a shark attractant color. I'll try to pull up that cool shot if I have it on here. So, you know, there have been incidences recently with the sharks being attracted to the robot. I'm not wholly convinced it's the color, but yeah, I think it was last summer here on the Cape. We had a shark incident. No permanent damage done. I don't think if anyone's watched the Shark Week with the Remus cam, those are some Hui researchers that took the Remus vehicle down to Guadalupe Island, and somewhat inadvertently found out that the sharks really like to attack it. And that robot survived many shark attacks and continued working. So
I've actually seen that robot, because when Hui does one of their presentations, they often bring it, and you can see the teeth marks in it, but it stood up pretty well to the beating that it took from that.
Yep, the housings on the smaller Remuses are hard anodized aluminum, and they're painted that yellow color on there, and they are pretty robust. I can say from personal experience that I've made my robot sample the seafloor or a seawall or the side of a boat a number of times.
As I recall from my tour, the Remus vehicles that are built for military are not yellow.
Sure. So you can choose a small range of colors that you want. There are applications where you don't want your robot to be visual on the sea surface. So some of our military customers will choose a gray color, which makes it look like a really cool little robot. When I'm out there and I'm testing my robot, I'd like to see where it's at. I'm not trying to be covert, so I'll cover it in yellow. But yes, there are gray ones out there, and black ones as well.
So there's a question.
Yeah, go ahead.
I was going to say there's a question about. I think this has to do with the configuration of the unit, and that is there an actual payload section, or are the sensors and everything just sort of integrated into the whole unit?
So there are a couple options there for that, right? With the traditional Remus configuration, the payload is and the electronics are kind of married in a similar section. There's always an option to put a different payload out front on the smaller vehicles. With the Remus 100 and 600, you can put a modular section out in the front end of it and put your own payload on there. With the new generation of Remus that we're going right now, we're modularizing almost all of that. The Remus 300, the shirt that I'm wearing right now, Mike and I are pretty proud of. It's a more modular AUV in the sense that you can take sections out and put different sections in, mostly batteries. So right now with the traditional Remus, you'd have to run your mission for however long it's going to be, then plug it into a charger and wait for it to charge back up. The next generation Remus will have hot swappable batteries. So if you want to go run your mission, bring it back up, you pop out a battery, put a new one in, and you're ready to go.
That's cool.
That now allows us to modularize the electronics section, right, that houses just the Remus bits and pieces to make it go. And then up forward, we could put modular payloads on there. So forward-looking sonar, camera systems, a suite of oceanographic systems can all be put on there. So we're moving more towards modular, and it's going to make the robot a lot more flexible for a lot more users.
Sure. So what do you see for the future of all of this? You mentioned the modularity. Is anything else that's coming up down the pipe that might be cool that you could share with us?
I think that as far as because we're providing the capability to get your payload down to the seafloor in a more flexible way, we're working on a little bit of open architecture that will allow you to develop your own capability within there. I think we're going to see a bit of a boom in optional payloads that can be built and put on an AUV that haven't been able to be there yet. More higher resolution sonars, laser scanning systems, new capabilities for looking forward. So getting different views of the seafloor that's on there. So we're going to provide the capability and the flexibility for the larger marine technology community to say, hey, now is a good time to work to get my system on an autonomous underwater vehicle. The modularity is going to allow customers a variety of capabilities, right? I mean, we can, the new REMUS 300 comes with 3 battery sections, right? One that gives you about the traditional capability of the REMUS 100. We doubled that. So now we're looking at 20-ish hours and still being 2-person portable. Mike and I can still lift that vehicle in and out of the water with that battery on there. And the next battery is going to be quite a bit bigger, giving you almost 30 hours of capability. So if you can imagine, you have multiple missions, multiple capabilities, and with those flexible payloads up front, you can send your robot out to make a seafloor map one day, and the very next day it can go out and take pictures for you, right? And if you had an oceanographic application, you just put the other battery on there and throw your oceanographic sensors on front. So it's going to give you a lot more flexibility within the same robot package.
Mm-hmm.
So
that's
those of you
cool.
who reported, I think that's going to be a really cool capability.
Robin, why don't you throw a couple more questions out? And
yeah, actually, we've got one here from Carol that might be above my pay grade. So I'm going to suggest that Carol Armitage, if you're out there, if you could unmute and maybe ask your question verbally.
Oh, sure. So as an applications engineer, Steve, are there any applications where you're faced with ethical dilemmas? In other words, drug lords want to use the vehicle for underwater drug deliveries. Have you ever faced anything like that?
Never faced anything like that, no. So by the time, the real world applications for these things, for mapping and mining the seafloor, outnumber anything else that people might want to do, that might have ethical considerations. So I don't believe Huntington Ingalls Industries would ever entertain something like that. That's a good question, though, right? I mean, now you see what this thing can do, what other things can do outside, the traditional applications, but nothing that I've had to interact with.
Steve, what's the longest REMUS mission that you know of?
The longest?
Yeah, how longest it was out.
Out and doing its job.
Yeah.
So I misplaced my robot for a couple of days once, and I considered it on mission for that amount of time. Right now, current capability is about 24 hours. Like I said, with the new REMUS 300, with the larger battery that we'll have on there, we're gonna push the 30-hour mark. So, but 24 hours is about maximum. And if you think about it from a shipboard application thing, right? If you're going to take a big robot out into deep water to do multiple missions, being on that 24-hour cadence allows the ship to do its other jobs, right? So if I put it in at 8 o'clock in the morning, I know I come back to that spot at 8 o'clock in the morning the next day. So, you also have to balance too. If we make a robot that go 30 or 40 hours, however long it's going to be, someone has to manage all that data that comes back. So there's a balance there between having a robot be out there persisting, a REMUS vehicle persisting for a long time, and then what do we do with those data? And they're different, than I heard of the gliders that can go out there for months at a time, but they're collecting very small data and occasionally coming up and sending that data back. But for REMUS, it's about 24 hours. Give Mike and I a couple more months, and we'll give you a 30-hour capability.
Okay, we got it. This is a fun question from Mark. Mark wants to know, what's the strangest thing that a REMUS has encountered?
Oh, I'm sure the REMUS has encountered all sorts of strange things. That's a really good question. I don't know if it's strange, if it qualifies in the strange capability, but, I ran a REMUS 600 for NOAA with a multi-beam sonar on there, and then we did some work over a poorly charted reef one time, and we were able to provide data back to the oceanographic community that totally changed their perspective of what that reef there in California was actually capable of doing. So wouldn't call it so much strange as an instance. You're able to get a view of the seafloor and a capability that you just can't get from a traditional shipboard system.
Okay, sorry, Mark, no sea monsters.
No sea monsters yet. So
we've got a question. Are other countries competing in the non-military sales of AUVs? Like how competitive is that market, and who are the competitors?
There are competitors in Europe. There's competitors in Canada that are making robots that touch more of the commercial market. We've our parent company, our old parent company, Kongsberg, made vehicles that were targeted towards like oil and gas, which is something that Huntington Ingalls Industries hasn't tackled yet. So there are applications outside of the seafloor mapping traditional that we envision that are being managed out there by competing companies. But there are a handful of foreign AUV makers out there in the world. And they're competing in a different space than we are right now. So specifically oil and gas.
Thank you, Steve. I've got a question that is about the current world situation. So could you just talk a little bit about how the pandemic has affected your business, if it has at all? But also, you know, as a robotics engineer, you know, what's being said in the world of robotics about how robots can actually step up, you know, when we're in a situation where human beings have to avoid each other?
Sure, no, it's a great question. So I'll tackle the first one first. You know, COVID's a thing. Huntington Ingalls Industries has done a really good job of allowing people who can work from home to work from home. We still have that stance. So if you can do your design work or your program management work from home, you're asked to stay at home. That's worked out very well for us. It had two effects, right? It allowed us to keep business as usual going from a business perspective, but allowed those of us who have to go in the office to touch robots to do their job a little bit more security, knowing that, you know, only being in the business in the facility if you have to be in the facility. You know, people like myself can't do everything I need to do from home, so it's comforting to know that the people who are there working on and building the robots have been the people who've been there since this whole thing started, and we're not getting outside people in there. You have to go ahead and if you're going to bring a guest in, they have to follow protocol set by the state for wearing masks. We're doing a good job of social distancing at work. We're limiting the number of people in each space to allow us to maintain that 6+ feet if we can. Masks are around, hand sanitizer is around. And I think that the win here for us is that I don't think we've slipped on any deliveries. I don't think anything has gotten delayed at all because of the pandemic. So the flexibility that our leadership has provided for us to continue doing our job has worked out very well. So as far as robots stepping up, you know, like I was saying earlier, my personal perspective was, you know, back to my NOAA days where we couldn't buy any more ships. But we had a mandate to collect more data. We tried to use those robots to, you know, expand our capability to go out there. So, you know, wherein if you're on a boat, say, and you're going to tow a sonar around to map your harbor or your bay, wherever it may be, you know, maybe you can't maintain that social distancing on that small boat, but you can get your robot in the water from the beach and launch it from there. So the robots are poised to be in a really good position to help keep work going for subsea applications for sure.
Do you know of anyone who is developing robots specifically to help in pandemics?
I don't. You know, I do use the term robot pretty liberally. My exposure to robots are very specifically to subsea robots. So, but I do see that, you know, this is the time to showcase if you do make a robot that can replace somebody physically being there. I think this is the time to start exploring that for sure.
Okay. So Bert, I think we have. Does anybody else have any questions? I'm looking through to see if we missed anyone. But I think we've got all the questions in the chat.
Right. There are some links in the chat to the Shark Cam, which is a lot of fun. I remember the first time I saw the Shark Cam video, there was a real jolt on the first incident.
Yeah. So thank you to Erica for putting that up. I don't think I could have played that to share the screen from here. And we missed out just a little bit. When I play that video, when you watch it on your computer screen, imagine seeing that projected in the room, right? Almost life size. It's pretty cool.
Sure.
When my kids were younger, I used to go do like you bring your parent to work day, so I'd actually bring parts of a robot, thinking that would be the coolest part. But no, one time I showed that video back there, and then all the kids remembered that. Yeah. So my son's name is Jack, and when he was in 4th grade, I guess I was Mr. Jack's dad. And when I would come over, other classrooms would come in there just to watch the shark video on the big screen there. And they weren't at all impressed with the robot parts that I brought anymore. So I always you gotta close with the shark video. Close with the shark video.
There we go. There we go. Are there any other questions for Steve out there? Well, here's a question. Any lessons for car autonomy? So is any of the autonomous technology that you're working on something that might be applicable for more general shoreside applications?
Sure, I think there's a good marriage there, that possibility. The car autonomy has is all about perception. Right? You look at all the autonomous cars that are out there, they're covered in cameras and trying to map and understand its world and relate that back to kind of build some kind of capability in there. We could do the same thing subsea, right? If we had some sense of where we're at, an old map, perhaps we can build that in, just like the car takes its pictures, and after a while it learns that here's where the stop sign is and here's where this turn is, right? Here's where my lanes are. The subsea robots can take that same type of information from seafloor stuff, right, or oceanographic information, and have some sense of where it might be. So I think that's kind of a cool application, right? We often send the robots out to do their job in largely unknown areas, right? So, but if we can give it a little bit of information to say, here's where we think the shorelines or the depths or features on the seafloor would be, just like how the cars are perceiving their arena. I think there's a good blend there and good capability.
That's great. That's great. Any other questions for Steve? All right, I know I had a request to show the shark video, but I think I'll just leave it. The links are in the chat, so you can go ahead and jump on that. If just for all of you, just grab one of the links in the chat, and you'll really enjoy it. Steve, thank you so much for being with us today. Any last words?
No, thanks for having me. Those of us who heard me talk about robots before know that I can do this all day. So I really appreciate the opportunity. Having the technology council here on the Cape, keeping their finger on the pulse of what's going on, I think is important. So we're always happy to talk with this group and answer questions that you might have. So
that's super.
Feel free to reach out. I offered it last time. We didn't get a chance to put it together. I think a tour of our facility is an awesome opportunity. So maybe when things settle down a little bit, I'll reach out to you, Bert, and see if people want to come take a look at where the robots are made.
Sure. I would love to come again and see all that. It's a great tour.
I'm there.
Yes.
Yeah.
All right. Well, thanks, Steve. Thank you so much. And I just want to thank everybody for being here today. We had a nice turnout for this. I appreciate you all supporting Steve and Huntington Ingalls Industries for what they're doing, and hope to see you next week. Robin, who do we have teed up for next week?
Next week we've got Jeremy Mayu from IT Works, and he will be talking about what's going on in the world of network management.
Sounds great. All right. Thank you all, everybody. We hope to see you next week or at some other online virtual event that we're doing. Enjoy the rest of your Friday and enjoy your weekend. Take care.
Awesome. Thanks, everybody.
Thank you, Steve.
Bye-bye.